Welcome to yet another episode of Top Linux Tech. In this video tutorial, we'll be configuring a file sharing server for your home network. Let's begin with the introduction first. So, what is an SMB file sharing or network attached storage server? Why would you want to run your own server? And what are the pros and cons of doing this on your own rather than buying a ready available proprietary solution? So, what is an SMB file sharing? Well, it is a server that allows you to share files and folders over the network, in this case, your home local network, with any other device by utilizing the server messaging blocks protocol. All that sounds nice, but why would you build your own instead of buying a nice new and shiny one? Well, the answer is simple. You are either an enthusiast that wants to build your own thing, or you simply do not want to spend an extra cash for a proprietary solution. And by the way, those proprietary solutions, they all run Linux or any other Unix variant as well. So you might be wondering what would be the pros and cons of building your own server for the job. Well, one thing for sure, it's less expensive. The server uses software RAID rather than hardware RAID controller, which is a major benefit here. Many proprietary products use hardware RAID controllers, which controls your hard drives, and in many other cases they also use a different CPU architecture, so if the hardware controller fails, it may be a lot more difficult to rescue your data, unlike the software RAID where you only have to attach the disks on another computer and your nightmare will be over in an instant. Another good reason is that these setups are perfect for the DIY enthusiasts, and you always have full control over the software and the options that are configured on such server, thus allowing you to use the best out of your resources and not just buying a server box that is bloated with tons of software. Not to mention, many of the cheaper ones are very slow. And finally, let's explain the cons. Well, one major disadvantage here is that you'll have to install and configure the server yourself. Of course, you're not going to have any support or warranty, and the setup might seem a little bit challenging if you've never used Linux before or if you aren't a tech-savvy person. But no worries, we'll cover most of your basic needs in this tutorial. Now, there are also other open source and free software solutions ready to go out of the box without involving manual configurations that are worth mentioning, and those are, for example, the Open Media Vault and Free NAS. So go ahead, click the links down below in the description and check those out. The reason of why we are going with this route in this tutorial is because we want the cheapest and the most basic solution available for us. For example, the Open Media Vault will require that you have 3 disks installed instead of 2, where one will be used exclusively for the operating system, and the Free NAS will require the same, plus some extra amounts of RAM memory due to the deduplication used by the ZFS Unix file system. So let me know in the comments down below if you will be interested in me doing some more videos on this subject involving these two fantastic open source and free software solutions as well. Anyway, before we move to the requirements, let's explain what is RAID and why are we using 2 disks for those of you that do not know. RAID simply stands for Redundant Array of Independent Disks, which allows you to merge 2 or more disks in a larger pool array from where you can gain either speed and extra space or redundancy by mirroring the contents of data between the disks. In this case scenario, we'll be using RAID 1, or also known as RAID Mirror, which will duplicate the same data on both disks, thus giving you redundancy in case one of the drives fail. In this case, you'll still be able to preserve and access your data without any loss. So let's see what are the requirements for this small home file sharing server. First, you'll need an old desktop PC, which should be no older than 5 years and should support EFI BIOS mode. This PC would need to have at least a dual or a single core processor with 2 GB of RAM and a network card. The PC will also need to have installed 2 mechanical or SSD SATA drives attached and ready to go. The disks should be wiped clean, meaning they must not contain any data or previous partitions. And finally, you'll also need a small USB flash drive of minimum 2 GB in size for the Debian Linux OS installation. And with all that being said, let's move on with this tutorial. To get the Debian operating system, simply navigate to debian.org website, click on Getting Debian, then click on the Download and Installation Image link, and finally, click on the link for your processor architecture. In 99% of the cases, if not 100, you'll want to click this AMD 64 link, and simply wait for the download of the Debian installation image to finish. Next, we need a USB flashing tool, so navigate to rufus.ie and download the Rufus flashing tool. Once the files are downloaded, make sure that you insert an empty USB flash drive of minimum size of 2 GB, plug it inside your computer into one of the USB ports, and then navigate to your Downloads folder and start the Rufus program in order to be able to flash the installation image. Once the program is loaded, simply choose your USB flash drive from the device list, click on Select, choose your Debian ISO image, click on Open, choose GPT as a partition scheme, and finally click on Start. Once the USB flashing is complete, remove the USB from your desktop computer and use it to boot the Debian installation on your server. Remember to choose UEFI from the boot menu options or set your BIOS on the server to boot from EFI mode. Okay, so if you have done everything correctly, and if your BIOS was set properly, then right after booting up from the installation USB, you're supposed to see this Debian GNU/Linux UEFI installer menu. If you do not see the EFI installer menu, then you should probably go back, reconfigure your BIOS to boot in EFI mode, and then restart the installation process again. Now here, on this menu, I'm going to go with the graphical installer. Simply select that and press enter. And the first thing that we need to do is select our language. So I'm going to go with English here, click continue. On the second screen, you're supposed to select your location. So choose your country, territory, or area. So I'm going to go with other. You can also double click on these options. So let's go to other. I'm going to choose Europe, and Macedonia is my location. So I'll go with that. For my locale settings, I'll simply go with United States, US English, and I'll choose American English for my keyboard layout. Click continue. Now we are waiting for the installation components to be loaded so that we can proceed with the installation. Now the network should configure automatically, assuming that you have DHCP enabled on your home router, and in 99% of the cases, you should have that option enabled by default. So you should be able to get an IP address assigned to this server automatically. If you don't have that, then you'll get an error saying that the IP address could not be obtained and you will have to enter it manually. So you'll have to choose an IP address that corresponds to your home network in that case. So next, we'll have to simply choose the host name or however we want to name our storage server. So I'll keep it simple and name this system storage server and click on continue. For the domain name, we do not have to enter anything. That's not important in this case, so let's click continue. And now we have to specify the root password or the super user password, or for those of you who are coming from Windows, this is quite similar to the administrator or the admin password. So let's give our root account a password. Make sure that you type at least some strong and secure password, even though this server is going to be on your home network and you probably trust it, but still you should make your passwords to be a little bit more complex rather than simple. However, in this case, just for the demonstration purposes, I'm going with a simple password. So let's click on continue. And now we're asked to create our ordinary user account. So we'll have to specify the full name for our user. And I'll simply call it Top Linux Tech. Click on continue. And for the username, or the short name for the account, this is actually the login name. I'm going to keep it simple and simply say TLT and click continue. Now we also have to specify a password for this user. And by the way, this will also be the password that you'll use to connect to your storage server. So make sure that this password is also a little bit more complex and quite secure. Again, for the demonstration purposes, I'm using a simple password here. I'll click continue. So basically now we have two user accounts in our system. One is the primary system top level account that is known as the root or the super user, and the other is the ordinary user account that we have just created. Okay, so all of that is set, and now we have come to the most important part in this whole setup, and that is the creation of our disk partitions and the RAID mirror. So in this case, we'll have to go with manual setup. Click continue. Okay, so on this screen, you're supposed to see your two disks that you have installed into your system. In my case, these are not real disks, but rather virtual disks, and as you can see, they are 50 gigabytes each. However, one thing to note here, which is very important, is that the disks that you have installed into your system must be clean, meaning they should not contain any partition or any configuration whatsoever. So make sure that they are clean before inserting them into your system. If they are not, if for example they already contain some other partitions, make sure that you delete those partitions from this partitioning utility or wipe them clean by assigning a new clean and empty partition table on those disks. So let's click disk number 1. We can also double click on it and choose to write a new empty partition table. So click on yes, click on continue, and immediately you'll notice that a 50 gigabytes of free space has been assigned to the disk number 1. Now let's do the same for the disk number 2. Click continue, new empty partition table, and that's it. We now have free space on both disks that will allow us to create new partitions and then configure them accordingly. Okay, so let's begin creating our partitions now. And the partitions that we create on the first disk will have to be exactly the same as the partitions created on the second disk and vice versa. So it doesn't matter which disk go first, as long as the partitions are created in the exact same order and size. So let's start with disk number 1. Let's double click on that and choose to create a new partition. Now for the first partition, we'll select a 500 megabytes of size and click continue. For the location for the new partition, we'll choose the beginning of the disk. And for the use as, we see that the ext4 journaling file system has been automatically specified, but this is not what we want. So we double click on that and change it to EFI system partition, because this is going to be our bootable partition. And also make sure that the bootable flag is on. So we click on done setting up the partition. And we'll see that under the first disk, there's partition number 1, and it has been created as ESP or EFI system partition with the size of 500 megabytes. So let's do the same for the second disk. Let's create a new partition. And it's going to be the same exact size of 500 megabytes. Beginning of the disk, use as, EFI system partition. Bootable flag is on, and we're done setting up the partition. Okay, so one very important thing to point out here. These two partitions are not going to be mirrored, meaning they are not going to be in our RAID field. Well, why is that? Because they have to be separate, they have to work with the grub bootloader, and they have to work with the EFI BIOS settings. So we'll have to configure these as separate but identical and identically configured boot partitions. Everything else will go inside the mirror RAID field. So let's click on the remaining of the free space of the first disk right after the bootable partition. Let's double click on that and let's choose to create a new partition, and this time we'll choose 2 gigabytes of disk space, which will be used as the partition that will serve as our swap file, or the swap partition in this case, which will serve as cache and a reserve RAM in case our system needs it. So 2 gigabytes of size, click continue. The location will be at the beginning, of course. And under use as, we're going to choose physical volume for RAID, because we also want to include the swap partitions to be part of the RAID field as well. So let's choose physical volume for RAID, click continue, done setting up the partition, and let's do exactly the same for the second disk. So click on the free space, new partition, size of 2 gigabytes, continue, beginning, use as physical volume for RAID. Done. Okay, so far so good. Now let's go back to the first disk and now choose to create another partition. And this time we'll specify 12 gigabytes here. And this will be the partition for our operating system, or the root file system partition, where Debian Linux will be installed. So click continue, beginning. Again, we'll change the type to physical volume for RAID. Done setting up the partition. Do exactly the same for the second disk. And finally, we want to use the remaining of the free space for our data partition, or for the partition from where we are going to have our shared folder on our home network. So you can either use the remaining of the disk space or specify any size that you want to use. It doesn't matter. In this case, I'm going to use all of the remaining disk space for my data partition. So I'll choose continue here. And of course, we're going to change the type to RAID. Done. Do exactly the same for the second disk. Alright, so far so good. So we have 4 partitions defined on each disk, and they are identical in size and in type. And right now, the only thing left to do here is specify the file system on each partition, because obviously we cannot use these partitions unless we format them with the appropriate file system. So let's go up here and choose the second option, which is configure software rate, and click continue. Now, before anything else happens, the boot partitions, they have to be written to the disk, so let's choose yes. And on this screen, we choose the first option, or create an MD or multi-disk device. So we can double click on that. Now, as the RAID type, we're going to select RAID 1, which is mirror mode, which will actually mirror the contents or the data from the first disk onto the second disk and vice versa. So let's choose RAID 1, click continue. Number of active RAID devices in the array will be 2. We're not going to use any spare device, so let's leave this to 0. Click continue. And now on this screen we have to choose which partition are the active devices, or the 2 partitions that are going to be mirrored between each other on each disk. So we'll have to do the pairings right here. Let's begin by pairing the swap partitions first. So let's now pair VDA2 with VDB2 and click continue. And again, we choose to create another multi-disk device. RAID 1 or mirror mode will be selected as well. So click continue, number of active devices 2. We're not going to use spare. And let's now pair VDA3 with VDB3 and click continue. And finally, the last multi-disk device that we have to create. So double click on that, RAID 1, number of devices 2, no spare, and let's pair VDA4 with VDB4. And we're pretty much done. So let's click on finish. And right now on this screen, we see all of our mirrored partitions. So we have the swap partition, the operating system partition, and the data partition. And right now we have to double click on each of them and choose however we want to use them or format them. So in case if you didn't notice, let's choose the RAID device 0, click under it on the 2 GB partition, double click on that and choose use as. And in this case, since this is a swap partition, we'll choose swap area and click continue. Let's move to the RAID device 1 or the operating system partition. And we're going to use this one as the ext4 journaling file system. Double click on that. And for the mount point, we need to select the / or the root file system. So let's use that and click done setting up the partition. Finally, let's configure the remaining RAID device number 2. Double click on that, use as, ext4 file system again. Now for the mount point, we'll have to enter this one manually because you're going to want to name your shared folder. So you can name it anyhow you like. In my case, I'm going to name this one /share. So this is exactly how I want my shared folder to be called. So /share and click continue. Done setting up the partition. And we see now that everything is properly configured and ready to go. So we have the swap, we have the root file system with the ext4, and we have the /share file system also to be formatted with the ext4 file system. So finally, we click on Finish Partitioning and write changes to the disk. Click Continue. Choose Yes to write the changes to the disk. And that's it. We have just passed through the most complicated part of this setup, which is configuring the partitioning and the RAID field for each device. And now we wait for the base system to be installed. Basically, these are the main operating system components, so it's going to take maybe a few minutes or less. I'm going to pause the video here and simply resume when it's done. Alright, that finished. So let's select no, we don't need to scan our installation media. So click continue. And now we need to configure our package manager or the mirror for the Debian archive or the server that is closest to our location or to your location from where you're going to install your server software. So in my case, I'm simply going to select my location or any location that's closer to me and click continue. I'm also going to choose the mirror that I want to use. For the HTTP proxy, we don't need to use that, so click continue. Okay, so now the package manager is going to be reconfigured, and we'll also have to select the software that we want to install on our server. But first, Debian will run apps update in the background and pull any updates that are available for the operating system. So we're going to have to wait for that to finish before we continue installing our software. This is also going to take maybe a minute or two. Okay, so the updates have finished, and here you can choose if you want to participate in the package year survey. I'm going to choose no. And now we come to the screen where we have to select our software that we want on our server. Now, since this is going to be purely a file sharing server, we do not need to have any desktop environment installed. If you want that, sure, you can go with that, but it's really better to simply tick this option off. Also, we don't need any print server. So the only two options that we actually need are the SSH server and the standard system utilities. Select those and click continue. Now we'll wait for those utilities to be installed and configured on our system. Finally, we are done. The installation has completed, and now we click continue to reboot our server. If everything went well, right after reboot, you're supposed to see the Debian GNU Linux grub bootloader menu, and simply press enter or wait for the auto start. Now here I'm going to use the root account to log in. So let me quickly set a bigger font so that you can see the information on the screen in a better way. So I'm going to use the set font command to change the console fonts. So set font /usr share console fonts, and I'm going to use the uni3 terminus 24 by 12. Okay, and before we move up with anything else, we'll have to check the disk synchronization process because it has already started. So let's do cat for concatenate on /proc/mdstat, and we see that the partitions are currently resynchronizing. Now this happens regardless if you have any data or not. They have to be in sync, so we'll have to wait until that completes. And we can actually monitor the syncing process live with the command watch-n1 on cat/proc/mdstat, and we see the synchronization process as it happens in real time. Now, the time for this resynchronization will depend on the size and on the speed on your disks. So make sure that the synchronization finishes before you can proceed reconfiguring your server. You can also skip this part and continue to install software in your server if you like. However, the performance will be slow until the disks are fully synced. So I recommend that you wait until the disks are in proper sync. For example, if you have something like 2 terabytes or 3 terabytes drives, this may actually take, probably it will take about 2 hours. So you should wait until the synchronization is complete before moving to the next part. In my case, these are 50 gigabytes disks, so as you can see, it's not going to take very long. It's about to finish in a minute or two, so we can resume with our demonstration. And it's done. So notice that we have 3 multi-disk devices. As if you remember from the setup, these are the MD0 or the swap partition, the MD1 or the operating system partition, and the MD2 or the data partition. Now, these are all properly synchronized except MD0. Now, if you see, it says active. However, it's in read-only and resync is pending. So we're going to fix this right away. But first, to break out or to get out from the watch command, because it is still active, you have to press Ctrl and C to get back to the shell prompt. And now, in order to start the resynchronization for the swap partitions, we'll have to put them in read-write mode and force resync again. So in this case, we'll use the command mdadm, which is the multi-disk administration tool, and we'll specify here --read write as option on /dev md0. And remember, the md0 device is the swap partition that failed to synchronize properly. So let's execute that, and let's do the watch command again. So now we finally see that the MD0 device is also synchronized, and basically all of our 3 partitions are now properly synchronized and ready to go. So let's press Ctrl and C again to exit back to the shell prompt. And finally install a couple of extra packages that we need in order to make this server fully operational. So we'll run the command apt, which is the Debian's package manager, -y install, and we'll choose to install the following packages. So first and foremost, we need the package for SMB file sharing, which is called Samba. So we need to install Samba. We also need to install sudo to be able to give any other user account a super user privileges or admin account if you want. Now we also need to install the ACL package, which is used for the access control lists that will allow you to do advanced file and folder sets of permissions that you can assign to multiple users and multiple groups. However, in this demonstration, I'm probably not going to explain that. We'll go with the most basic and the most simplistic setup. And probably in the later videos, I'll also explain how the ACL command works. But anyway, let's install ACL as well, regardless if we're going to use it or not. And the next package that we also need is smartmon tools, which is a diagnostic utility for your hard drives or SSDs. So basically, these utilities will actually alert you or send you signals if there is something wrong with your disks or if they are failing, so that you know that in advance. Let's also install htap, which is a process monitor, MC or Midnight Commander, which is a file manager, and iftop in case if you want to simply monitor your network stats. So we have Samba, sudo, ACL, smartmon tools, htop, MC, and iftop. Press enter. And of course, we wait for the installation to finish. Now, use Win settings from DHCP. No, we're not going to use that. We don't need that. Alright, so that's finished. Let's clear the screen and let's also clean the apt package cache. So let's run the command apt clean. So this will basically clean all the downloaded software that we have just used for the installation. We no longer need those packages, so it's safe to clean them. And finally, since we're going to actually administer this server remotely, we have to make it accessible. So let's use the nano editor to modify a system config file. So type in nano /etc/ssh/sshd_config and press enter. So use the arrow keys on your keyboard to move down until you find the option permit root login. So if you can see, there is a hash symbol before permit, which means that this option is commented or using the default settings. So we want to comment that out to enable this option and change the permit root login from prohibit password into yes. So basically this will allow you to log in via SSH with the root account. And this is of course if you want to do it this way. But I recommend, since you are on your home network, that you use your root account to do system modifications. So permit root login, yes. And since we're done, we can press Ctrl and X to exit. But before we exit, we have to save and write the changes to this file. So we type in Y to confirm the changes and finally press enter. And that's it. We can clear the screen now and simply restart the SSH daemon with the command systemctl restart sshd. Press enter, and that's it. Okay, we're almost there, but before we power down this server, we'll have to get its IP address so that we can use it to connect remotely and perform the rest of the setup. So to do this, we can execute the command IP addr and press enter. Now, in my case, I only have 2 entries, and you will probably have only 2 entries as well, because in 99% of the cases, you're going to have only one network adapter in your server. So right now you see 2 network adapters listed here. The first one is the LO, low, or the loopback adapter, and that one you shouldn't be concerned with at all. So pay attention to the second one. It can be IT0 or ENP1S0, like in my case. So look for where it says INET, and then you'll find out your IP address. In my case, this is 192.168.150.32/24. So that is the IP address that we want. If this screen is somewhat confusing, you can also use the command networkctl status and look for where it says address, and there you will find the IP address that you want to use. So in my case, again, this is 192.168.150.32, and yours will probably be different. That will reflect your own home network settings. So you should write that address down and finally power off your server. And to do that, simply run the command power off and press enter. And basically that's it. From this point on, your server will power down, and the only cables that you should have attached to your server are the power cable and the network cable. So make sure it's set up like that, power it on, and from now on you can use your other operating systems to remotely connect to your server via SSH or via the graphical software utility that we're going to install, or the control panel from which you are going to manage your server. Okay, so when it comes to managing your server, there are multiple ways of how we can do this. We can either use an SSH connection, or we can install a control panel. Now, for those of you who are already using Mac and Linux, you probably already know how to establish an SSH connection to a server. However, for the rest of you who are using Windows, well, there are actually a few ways of how we can achieve this. So, if you are on Windows, you can actually use the Windows terminal to accomplish this task, or you can have a third-party program installed on your computer, something like Bitwise SSH client, for example. Now, I'll tell you how to get both. First of all, in order to be able to use the Windows Terminal app, you'll need to have the Windows subsystem for Linux already installed. You can achieve this by going into the control panel, click on Programs and Features, then click on Turn Windows Features on or off, and make sure that the Windows subsystem for Linux is ticked, and then click OK. You might be asked to restart your computer after that, so go ahead and do that. And if you already have enabled the WSL option, then you can simply navigate to Windows Store and do a search for Ubuntu 2004. Just type in Ubuntu. Make sure that you click and install Ubuntu 2004 LTS system. Now in my case, I have already installed Ubuntu Linux within my Windows machine, so I'm going to skip this part. However, after you install Ubuntu 2004, make sure that you also search for and install Windows Terminal. So type Windows Terminal in the search, and then finally install the app. Now again, I have already installed this app into my Windows machine, so I'm not going to do it over again. The installation process is quite straightforward and simple, so I'll leave you to that. But right now I also want to show you the second alternative, in case if you don't want to bother with a Windows subsystem for Linux and all these separate installations. You can simply open up your web browser and do a search for Bitwise. So Bitwise, Wise spelled with a V. Go ahead and click the link www.bitwise.com. Go to the download section and simply download the Bitwise SSH client. You don't need the server package, just the client. Once that is downloaded, simply install the program and run it. That's it. So I think now it is finally time that I show you how to connect via the Windows terminal or the Bitwise SSH client. So let's start with the Windows terminal first. So let's first start the terminal, and if you have the WSL already installed, here from the down arrow next to the PowerShell tab, you can click and select to run a new Ubuntu session. So let's do that. I'll click on Ubuntu. I don't need the PowerShell tab open, so I'm going to close that. And just like that, we are right now inside our Ubuntu Linux machine that is running from within our Windows virtualized or containerized environment. So let me make this font a little bit bigger. I suppose that's fine. And I'm also going to position myself inside my home directory by typing in cd and tilde. Now, positioning myself into the home directory has nothing to do with this. I simply want to eliminate this path here to be shown on the screen, and that's it. So let's finally establish an SSH remote shell connection to our server. All we have to do here is simply type SSH space root at, and now we simply type in the IP address of the server. So in my case, this is 192.168.150.32 and press enter. Now, if this is the first time that you're connecting to this server, you're going to be asked if you are sure and if you want to continue connecting. So type in yes, press enter, and finally provide your root account's password that you have set during the installation of your server. Type in the password, and that's it. We are currently logged in via remote secure shell connection into our server. And we can now finally finish configuring this server and install the control panel from which we will use to fully administer the server from now on, because I suppose that for many of you, trying to do these things from an SSH connection is going to be somewhat inconvenient or maybe difficult, especially if you are somebody who doesn't know much about Linux. And for a change, I wanted this video to be actually geared for everybody, specifically also for Windows users, not just for Linux users. And that's why we are actually going to use a nice graphical user interface in order to configure the server further on. But before that, we'll have to install it. Okay, so the first thing that I'd like to do when usually connecting to a Debian system is enable the color output for my console or the terminal. And this basically helps me to distinguish other details and things better. So it's a nice feature to have, although it's not mandatory, and this step is quite optional, so you don't really have to do it. But I must do it because I want to. So since I'm already inside my root home directory, I'm simply going to edit this bash rc file and enable the color output. So I'll use the nano editor in this case and simply edit the file. All we have to do is uncomment the ls options for the color, Control X, Y, enter. And I'm going to exit and reconnect to the server again in order for these settings to take effect. And that's it. We have color output. Okay, now let me also show you how to connect via the bitwise SSH client in case that is the method that you prefer to connect to your server. So let's run the program. And when the program starts, inside the host field, simply enter your server's IP address, 192.168.150.32 in my case. For the port number, just enter 22, and then in the section on the right where it says authentication username, type in root. For the initial method, choose password. You can choose to store encrypted password in the profile and also specify your root account password. So type that, click on Login. You can click here on Accept and Save, and that's it. If you see this new terminal console icon here, that means that you're already connected to your server, and all you have to do is simply click on this terminal console and the terminal window will open, from where you'll be able to manage the server in the exact same way as if you're using any other terminal program. And when you're done working, you can simply end your terminal session by typing in exit, press enter, and simply click on logout. Click the exit button and that's it. Now there are two remaining things that we need to do before we actually configure our file shares. And that is, number one, we'll have to complete our bootloader configuration. And number two, we'll have to install a graphical control panel that we can access from our web browser so that we can actually manage our server via a nice graphical and more intuitive way. So let's begin with finishing the bootloader setup in this case. Now, currently we only have one active and configured boot partition which resides on the first disk. So if we run the command ls blk to list block devices, we'll see that we have two disks in our system, as you already know. That's VDA and VDB. Now the boot partition is currently active and mounted on the first partition of the first disk. And even though during setup we have already assigned the first partition of the second disk to be also a bootable EFI partition, however, it is not yet configured. And it also contains nothing at the moment. It just sits there empty. So imagine a scenario if, for example, this hard drive were to fail. Well, your system will continue to operate and will be able to boot because the current active boot partition is on the first disk. So you have nothing to worry about. However, imagine if this disk fails. If the first disk fails, then in that case you'll not be able to boot your system from the second disk because the first partition is, or the bootable partition, is not configured. And remember, the boot partitions of the two disks are the only partitions which exist outside of our RAID mirror configuration. So we'll have to set the redundancy here manually. So the first thing that we need to do is actually clone VDA1 partition onto VDB1. And for this we can use the dd program in Linux. Don't mind the name, it's just called the dd and that's it. You can think of it as a disk duplicator, or maybe you can also think of it as a disk destroyer, depending on what you're trying to do and from your point of view. So anyway, let's use dd and let's specify the first partition of the first disk as the input file. So if, or the input file, equals /dev/VDA1. And again, in my case, it's VDA1 because I'm using virtual disks. And in your case, this is probably going to be SDA1. So make sure that you type things correctly. Okay, and then we specify the output file. So OF equals on /dev/VDB1 in this case. We can also set the status flag here if you just like to observe the cloning operation. So we can type in status equals progress and then press enter. And there we go. The partition is currently being cloned. Okay, so far so good. So right after the cloning operation is done, we'll have to add a secondary EFI boot menu item on the list so that the second disk will also be able to boot in case the first disk fails, and vice versa. So in order to examine the current boot order list for the EFI, we'll run the command EFI boot mgr and use the verbose flag, so -v, EFI boot mgr -v, press enter, and this will enable us to see all of the EFI boot menu entries that exist currently for our system, and there under 005 or the boot order number 5, there is our Debian EFI boot entry listed and specified with the current first partition of the GPT disk with the following UUID, which is actually our first VDA disk. Now, if you want to check the unique identifiers of every disk, you can run the command blkid, and this will actually list all of the unique identifiers that exist in your system. So, for example, you see that this unique identifier corresponds with this unique identifier for VDA1, which is the same. And this, of course, means that our operating system will only be able to boot from this option and from this partition only, as I have previously mentioned. So let's add the second item on the list right now. Let's first clear the screen, and let's run the EFI boot mgr again, just for reference. And now let's execute the same command yet over again, however this time with different switches or different flags. So we can run EFI boot mgr -c for create a new entry, and then -g because this is a GPT disk. Normally in every EFI UEFI setup you have to work with GPT disks. And then finally -d for the destination disk, and in this case this one is /dev/vdb, so that's the second disk. And then we specify -p1 because this is going to be the first partition of the second disk that we want to work with here. And then we specify -L, open up double quotes, and in between those double quotes we can specify the name for the boot menu item, and we can type any name we want. However, let's keep it simple and call this Debian 2, for example. That will suffice. And let's specify the final switch here, -L in lowercase, and also open a single quotes here. And within those single quotes, we'll have to type in the path of our EFI grub bootloader settings file. If you're not sure about the file path, you can find it right here in the above reference. So it's /EFI/Debian/shimx64.efi. So we'll have to use this one. So it is with backslash this time. So /EFI/shimx64.efi. And when you're done, press enter. You'll see that the boot menu item number 6 has been added, and this is the Debian 2 option that we have specified for the second boot partition that is found on the secondary disk. We can also double check and verify everything by typing in EFI boot mgr-v for verbose, and we can see the both boot menu items listed properly with their respective unique identifiers. Okay, now once this is done, we'll have to save the settings by updating our grub bootloader. So the final command that we need to run here is update-grub and press enter. Once the bootloader has been successfully reconfigured and updated, finally it's time to restart the server and test if everything is okay. So we can execute the command reboot and press enter. This will basically drop us out from the server's terminal session and revert us within our local terminal session that runs on our Ubuntu Linux, which runs within Windows. I hope that makes sense. So you should at least give your server a minute or two to be able to boot again. And right after that, simply reconnect or re-establish a new secure shell connection to your server by running the same command, ssh root at your server's IP address, and press enter. Type in the password, and there you go. Now let's actually check if the second boot menu entry exists and that we have done everything correctly. So let's run EFI boot mgr-v, and yes, we can see that the two boot items are found on our list, which means that we have configured everything correctly. In case if you're missing this secondary option, that means that something went wrong or you've made a mistake, so we have to repeat the process all over again. Anyway, let's install the control panel now, and once we do that, we'll no longer need to administer this server via SSH connection. So no more terminals for those of you who actually hate them. Let's clear the screen here. Okay, open up your web browser and simply type in Webmin in the search bar. This will take you to webmin.com website. And from here, simply go to the download section. Choose the Debian package suitable for Debian, Ubuntu, or other derived Linux distribution. And to get the link, simply right-click on the HTTPS link and choose copy. Go back to the terminal, and here simply type in wget and right-click to paste the link. Now, depending on the terminal that you are using, it can be either right-click or Control plus V, or maybe Control plus Shift plus V, or maybe Control and right-click. So you have to figure that one out. But anyway, in Windows Terminal is simply right-click and it pastes the last value from the clipboard. So wget and then paste the link and press enter. And this will actually download the software package. Alright, let's clear the screen. And let's list the directory contents by executing ls-al. Press enter. And here is our package. Now it is downloaded, and the only thing that we need to do is simply install it into the system. And for this we can use the dpkg or the Debian package system with the -i option for install, and then simply specify the package name. So we can type the first two letters of the name and press tab to autocomplete. So dpkg-i and package name, press enter. And this will install the package into our system. Okay, so it appears that we also got a few errors that were encountered while processing the installation package, and this is probably because of missing dependencies. Now this can be easily fixed by running apt-yf install and just press enter. And this will actually pull all of the missing dependencies and reconfigure the failed package. So as you can see here, it says setting up Webmin, and that is exactly what we need. And finally, the Webmin control panel has installed without any problems. So we're all good to go. As you can see here, it says you can now log in to https:// storage server 10,000, which is the port number. So you can either log in to this web address, or you can also use your server's IP address instead. So let's try now and log into our storage server. Let's type in https colon // storage server colon 10,000 and press enter. And you'll get this error message saying that your connection isn't private, and you'll also get not secure here in the address bar. But this is nothing to worry about because you're only connecting to your private network, and regardless of the error message, your connection is still encrypted with SSL traffic. So simply click on the advanced and click continue. So this will open up the login screen, and here you'll have to log in with your root user account again. So type in root and the password that you have assigned to the root account. You can tick the remember me option and click on sign in. And just like that, you'll be redirected to the dashboard. So pretty much on this dashboard, you can see all of the stats regarding CPU, memory, and swap usage. We can see now that our server is using, for example, 15% of our RAM memory and 9% of total local disk space usage. You can also click down here on disk usage, and you can see that, for example, your share folder is using this amount of free space, which will be shown in percentage and in gigabytes as well. You can also click here on the bell icon, and you'll get a nice overview of all of the details. Maybe you'd like to change the theme, so you can set your dark theme here by clicking on the day-night mode. So maybe you prefer the dark theme or the light theme, that's completely up to you. For this demonstration, I'm simply going to revert back to the light theme. But notice right here where it says package updates, it currently says that all packages are up to date and there's nothing that you need to do. However, in future, you should pay attention to this because there will be some operating system updates available in the future, and you might want to also install them when they are available. So anyway, the only things that you would probably want to use from this control panel will be the system category right here on the left pane, from where you can add users and groups that you would want to define for your file shares. Next, you would actually want to configure your Samba Windows file sharing application. And finally, you would probably want to monitor your disk health status, which can be found here on the Hardware tab. So basically here you would want to check your Linux RAID status and your Smart Drive status. And SMART, by the way, stands for Self-Monitoring and Report Tool, which is a diagnostic hardware utility chip built into your hard drive, which keeps track of your disk health over time as you use it. So let's click on the Linux RAID option here. And immediately you'll notice your three partitions that you have configured for the RAID mirroring to be displayed and their status. So all you need to worry about right here is the status. If it's all green and if it says clean or active, then that means that the RAID mirror is operating normally. However, if you encounter something like degraded or bad or missing, and it will usually be shown in red, that means that you have problem and that you might actually need to reconfigure the RAID array or maybe fix it, resync it, or that actually there's something wrong with your disks. If something like that happens, then you need to check this Smart Drive status option here. So let's click on that. And all you have to do here is simply select the disk for which you want to run checks and click on the Show button. Now, unfortunately, I am only using virtual disks, so they do not support SMART, which means that I cannot show any diagnostic data. But for real disks, you'll be able to see if there are any physical problems. So basically, you're supposed to run periodic checks in order to make sure that your hardware is always in a peak physical condition. Now, the one remaining tool that you will probably want to use is here in the Tools section, and that is the File Manager. So let's click on that. And from here, you'll actually be able to set the files and folders which you want to share and also give the appropriate permissions for users or group accounts. Now, if you remember during setup, we have specified the shared folder as our share partition and the folder which will contain all of our shares, meaning files and folders, or content that we want to share on our home network. So, in this case, we'll be working with this folder. So go ahead and click on that. And this will bring you inside the directory, like with any file manager. And here, let's, for example, create two folders for this demonstration. So I'll go here to the File menu, click on that, and select to create a new directory. Let's call this directory public, for example. Let's click on Create. And let's also create another directory. And this time, we'll call this one private. So in this scenario, I'm setting up two folders, one with private access only, and the other with public access or free for all. So let's now first create the private access folder. Now, if you see here in the owner section, let's actually zoom this page a little bit so that you can see better. Hopefully that's good enough. Okay, so let's first configure the private folder. As I said before, we'll use this one for private access only, so we'll have to change a few settings. For example, we see here that the owner defaults to the root account, and that's not what we want. So we can right-click on this folder, go down to Properties, and click Change Ownership. And here, basically, you'll want to change the username and the group name to your own user and group in order to be able to access this folder. So in my case, the username is called TLT, and the group also has the same name, which is automatically created during setup. And whatever you do, make sure that you tick this recursive box option, because it will allow you to specify the same ownership for the other folders and files which exist within that parent directory. So in most cases, you would want to apply these settings everywhere within the directory tree. So let's click on Change. And now that we have set the owner and the group to default to our username, we also need to change the permissions. Now currently they default to 755, and in this case we need 750, which will give us access only to our user, our group, and not to everybody else. So let's right click on that, choose Properties, and click on Change Permissions. So here we want the owner to have read, write, and execute permissions. The group is pretty much fine with only read and execute permissions. However, for everybody else or for the others, we need to tick these options off and allow no access whatsoever. And also down here where it says apply to, we'll also use the recursive option. So choose all recursive and click on change. Now, before we configure our public folder, let's actually go ahead and add a guest user account and a guest group that will be used for everybody else. So let's go to System, Users and Groups, and here we can click on Create a new user account. For the username, We can use the name guest123, for example. It's up to you to come up with any username that you want to use for your guests. We'll leave the user ID to automatic. We don't have to specify real name or the home directory. The shell, well, it's not that important because, well, obviously they are probably not going to log in via SSH, but just in case, make sure that you change the shell to bin bash in this case. Now for the password, we want to go with the normal password, and we can assign the same password as the username or any other password, so it's completely your choice and up to you. In my case, I'm going to use guest123, the same password, just to keep it simple. Now, for the primary group, we want to give this user to have its own group name to be identical to the username. So we want to click here on the new group with the same name as user. So select that option. And we also want to add this user into a secondary group, which is called Samba share. And if we scroll down, we'll find it down at the bottom of the list. So let's click here, and we can see that the user account has been added to the Samba share group as well. And by the way, you might be wondering why we are assigning secondary groups to users. Well, groups are more convenient when it comes to file and folder permissions management because they allow you to specify a single set of permissions for multiple users at the same time if they belong inside a group. So, rather than having you manage a permission set for each user independently, you can do that at once if you have multiple users belonging in a single group, and then you only manage permissions and access for the group itself, which contains all of these other users. So in this case, it's more convenient to do management this way. Right now, all we have to do is click on Create, and we are finished with creating our guest account. Now let's go back to the file manager and reconfigure the file permissions for the public folder. So let's click on Share, right-click on Public, choose Properties, and then change ownership. Now in this case, for the username, we'll change the owner to our user account. However, for the group name, we'll use that secondary group that we have just specified, which is Samba Share. So let's type in Samba Share, and let's also click the recursive option and click on Change. Next, right-click on that same folder, choose Properties, and click on Change Permissions. So right here, we want to give the owner, which is TLT, read, write, and execute full permissions. And for the Samba group, we also want to give read, write, and execute permissions. We can leave all others to read and execute, and apply this to all recursively and click Change. So we are done setting up our private and public share folders, and we are also done with our user accounts. So we have our own user account, and we have one more account for the guest or the public access. So the only thing that remains to be configured now is the Samba file sharing service itself. So let's go to Servers and click on Samba Windows File Sharing. Okay, so first things first. We don't actually have to share all of these home directories, printers, and all of other predefined factory shares. So what I'm going to do next is simply delete all of these unnecessary shares and make sure that we start clean with a clean setup. Before we configure anything else, we'll also have to make sure that the user accounts and the group accounts that we have defined are also synchronized with the SMB file sharing service. So let's click down here where it says Samba Groups and simply add the Samba Share group to be available for the SMB service. So in the group name, we'll specify Samba Share. For the group type, we'll leave this to the default or as the local group. And for the Unix group, we'll click here on the group icon and choose the Samba Share group. Make sure this one is selected down here and click on the select button. Finally, click on Create. And that's it. We have assigned the Unix Samba Share group to be also available for the Samba service. Let's click on Return to Share List and do the same for our user accounts. So this time, we click on the Convert Users option here, and we select the user accounts that we want to convert from Unix type into the Samba Share type, in the same way as we did with the group. So let's click here on this option which says Only Listed Users or UID ranges, and click on the user icon. Let's select our own user account. Make sure that's selected down here. Click this option to use this password, and here make sure that you enter the same user account password that you have assigned for your own user account during setup. It's actually much easier this way. Once you enter the password, click on Convert Users. Let's return to the share list, click Convert Users again, and repeat the same procedure for the guest account. Remember again, we are specifying the same Unix account password. In this case, I'm going to type in guest123 for our guest account. We can verify that everything is set correctly if we click here on the Samba users, and we'll see that our own user account and the guest account are now actually listed as Samba users. Okay, so now we can click on Restart Samba Servers button here to restart the service itself, and we can finally define the file shares and the permissions. Now this might seem redundant a little bit. You're probably asking, didn't we just do that from the file manager? Yes, we did that, but that was only relevant for the user accounts, which are using the pluggable authentication module as the only authentication within the system. However, since we are also using a Samba Share file service, we need to make that same authentication work with the service itself. So right now we are configuring the SMB file sharing options, and we need to click this option here, Create a new file share. For the share name, let's keep it simple and assign the same name that we have assigned to the shared folder, which is in our case named share. Next, click here on the file icon to choose the directory that we want to share. And from the file manager, we simply click on the shared folder, which is named share. Click on select, and then finally click on create. Once this is done, click the share name that we have just defined, and click on security and access control down below. Make sure that the writable option is set to yes, and then as valid users and valid groups, we want to assign the usernames and the groups that we have previously defined. So let's click here on the user icon, click on our guest account, and click on our user account. And once they're both selected, simply click on select. And for the group, you probably guessed it, we'll simply choose the Samba Share group here and click on select. Once this is done, click on Save, and finally click on File Permissions. Now for the new Unix file mode, we'll have to change this to 644, and we'll leave the Unix directory mode to 755 as the default. So click on Save, click Return to Share List, and once more click Restart Samba Servers. And we're almost done. However, we still have to reconfigure and to add a few more modifications to the main Samba config file. So let's click here on Edit Config File. Scroll down a little bit, and you'll see this option where it says workgroup equals workgroup in all caps. Now, if you're using Windows, make sure that your Windows workgroup is set to the same name that you see it here. If it is not, you'll have to change this to the workgroup that you prefer. Anyway, this is just a name. However, in order for the name servers to be able to function properly and to allow you to see the server listed inside your Windows network locations, this workgroup name has to be identical in between the server and your Windows machines. Anyway, you can easily check the workgroup name on your Windows machine if you right-click on My Computer or this PC and choose Properties. And here in the Advanced System Settings, if you click on the Computer Name tab, you'll be able to see your workgroup name. Now you can easily change this by clicking on the Change button, and you can name your workgroup whatever you like, but make sure that the workgroup name is, as I said, identical on your server and on your Windows machine. So once you have that out of the way, scroll to the bottom of the file, and here you'll find the settings for your share folder. Here everything looks fine, except that maybe you'd also want to add the browsable option. So type in browsable and set this to yes. So this will actually enable file and folder browsing from within Windows network locations. Click on Save. Click Return to Share List. And one more time, click Restart Samba Servers. So up to this point, it seems that we have configured everything that we need to configure. And now let's actually test and see how our file shares are working. So I'm going to minimize this, open up the Windows File Manager, click on Network, and here, if everything is set up properly, you're supposed to see your server listed alongside with your Windows machine. Now in my case, since I'm using a different type of network settings, and this is all a virtual network, I'm unable to see my server mapped in this location, but now that's completely fine. But in your case, you're supposed to see your server represented with an icon, and if you do not see that, simply restart your Windows machine. If you get a message stating that file and sharing is not turned on for your Windows machine, simply click on the message and turn on file and sharing for your home network. Now, depending on your network and firewall settings, this can be either public or private network if you're running Windows 10, or if you're on earlier versions of Windows, you can get something like guest, home, and business type of network. So make sure that you select work network, home network, or private network. Just don't select the public option. Now, since we already know our server name, as we have named it storage server during the installation, we can also access it by clicking here in the address bar and typing in \/ and the name. or you can also type in the IP address. In this case, I'm simply going to type in my server name, which is called storage server, and press enter. Immediately you'll get prompted to enter your username and password. So let's try logging in with our username account first. So in this case, this is going to be TLT. Type in my password, click OK, and there we go. We have our private and the public folder set. Now let's try put some files in here. I'm going to go in my private folder and maybe choose to create a new Excel document. Let's call this one payments, assuming this is the private folder and we want to keep this content safe. Let's type in something, click save, that's it. Can also create a new folder, for example. Let's call it test. Inside my public folder, maybe just create some other folders like, I don't know, music or pictures, for example. And as we can see, our file share is now working perfectly. But let's now repeat the same scenario and see what happens if a guest comes in and tries to access our share. So in this case, I'll simply have to log off and log back in order to simulate a guest account. So let's end this server session here and my terminal session. Click on log off or sign out, and then simply sign back in. And the reason why I am signing off and signing in back again is because Windows remembers my file share credentials, and if I try to access the folder again, it will simply not prompt me for the username and password. So I'll have to cycle through a login one more time. So let's assume that I'm a guest user now. And I click the file share. I go to the network. And of course, from my virtual network, I will be unable to see the server name here. So I'll simply type in the name again. // storage server. And if you get this error message, simply just wait up a minute or two until Windows gets its network refreshed. Let's try to ping the storage server to see if everything is okay. And yes, it is. The name seems to be existing on our network, so let's try that again. And there we go. Let's double click on that. And now let's enter guest123 as username and our guest password. And now we have access. However, if I try to go inside this private folder, I'll get network error, permission denied. But for the public network, well, I'll be able to access it as guest, and I'll also be able to create new folder and upload some files. So I'll call this one upload. Now for the other folders, for example, I'll get permission denied error when I want to create files inside. Well, this is because when we created these folders, these were created with the TLT or the username account as owner. So currently guest has no permission to write into these folders, but it has permission to write anywhere else within the file system. So if we want to correct this, we can simply go again to our control panel. So HTTPS storage server, And we can go to the file manager again. Click our shared folder, go inside public, and change the ownership for the music and the pictures folder, in case if we still want to give the guest account more permissions. So let's change ownership to TLT and Samba share. Let's do that recursively. And let's also change the permissions. So as you can see, you have full control over every folder and every file on your home network's file share. So now, while we are logged in as guest, let's try going into the pictures folder and create a file name here, or a folder. And as you can see, everything is working perfectly fine. We still no longer have access to the private folder, and that seems fine. Now let's sign off and sign in back again into Windows, because now I want to use my own user account for the file share. And in this case, I'd like my user credentials to be remembered by the operating system. So let's access the file share one more time. So I'm going to use my user account right now and click on Remember Credentials this time. There we go. Now, if you're wondering where does Windows store and remembers these credentials, well, that can be set in the control panel. When you open it, you'll see this Credentials Manager option, so click on that. And here under Windows Credentials, you can see your stored credentials for your file shares. So you can either edit or remove them by choice. Also, another convenient thing that you would probably want to do is map this share to be available as a network share. So click on this PC, click here on the View tab, or I think it was on the Computer tab, yeah. So click on the Computer tab, click here on Map Network Drive, add Map Network Drive, and for the shared folder, we can type in our shared path with the following format: // and then our server's name or the IP address, and then / again, and here you specify your shared folder. In this case, it's called share. So I want to have the reconnect at sign in option to be ticked on, and click on finish. And this way, every time when you access my computer or the Windows File Explorer, you'll see your share mounted as a network location, as if it were a physical disk, and you'll also be able to see the remaining disk space available, which is, well, nice and convenient way of how you would map your network shares. So everything seems fine, and we have successfully configured our home file sharing and storage server. If you are running Linux or any other Unix-based operating system, the way of how you would connect to an SMB share is simply specifying the SMB share address from within your file manager. For example, here I'll click down here in the address bar And I'll type the address smb colon / 192.168.150.32, which is the address of my SMB file server, and press either enter or connect. And there it is. The shared folder has appeared, so I'll simply double click on that. I'll get the username and password prompt, so you'll have to select registered user and type in your username and password through which you want to connect. You can either choose to remember the password forever until logout, or forget the password immediately. It's really up to you. So let's click connect, and there we go. We have our private and the public folders available. When you're done, simply eject the mounted file share from within your file manager, and that's it. Alright, now let's try to simulate a few failing scenarios. In this first example, I'm actually going to remove one of the disks into my system and see if the system will continue to work and if it has all the data that I need. So let me list here the block devices on this server, and I'll actually choose to remove my first disk from the system. So this will serve as a perfect fail case scenario. So let's power the system down by typing in power off. And this is how you would actually want to turn off your server in case if you just wanted to shut it down. You can simply type in power off and press enter. Okay, and it is done. I have removed and completely destroyed one of the disk drives. So let's try connecting to the server again. And let's list block devices again. Let's run lsblk, and now we only see that we have only one disk available, and that's VDA. Now, previously, this VDA disk was known as VDB, or the virtual disk B, because it was the second disk. But since I have removed the first disk, now actually the virtual disk B has reverted back to virtual disk A, and this is simply a naming convention. So please don't get confused by the naming scheme here. These are virtual names, and they get assigned always in order or in sequences as you add or remove drives. So regardless of the name, this disk used to be my second disk, and now it is the first disk into our system. So it's called VDA. Anyway, my storage server is now operating with only one disk, so let's see if the data is still here and it is intact. And yes, everything seems normal. All my data and all of my files seem to be here, which means even though we have simulated a hardware failure on one of our disks, the other disk has still resumed with a normal operation, and the server is now waiting for us to replace a brand new disk into the system and to resynchronize the data. So let's see actually what the control panel says. Just for a reference, I can run the command cat on /proc mdstat to check on my RAID array. And here, for all of the multi-disk configured devices, I'll see that actually only one disk is available out of two. So the multi-disk tool is reporting everything as it should. And let's also see if the same thing is reported from within the control panel. And it should be, because the control panel is also using the same underlying service. So let's go to hardware and let's go to Linux RAID. And we see here that the status of our mirrored partitions or the multi-disk is now all degraded. which obviously means that one disk is missing. So what I'm about to do next is insert a new blank disk into the same system and see how we can resynchronize our RAID configuration and make sure that they are back into the active and clean state again. Okay, so let's reconnect to my server again. And let's run the lsblk command to list all of the block devices. And now we see that two disks are again present in our system. However, the new disk is currently unconfigured. So it's listed only as VDA, but it is completely blank. Now, before we can use this disk back into our RAID mirror configuration, we'll have to create a new partition table layout on this disk that will be identical as with the existing operational disk. So luckily, in order to save us from the trouble from creating partitions manually, we can use a nice utility here that will actually instantaneously clone all of the partition tables that exist on the VDB disk back on the VDA disk so that we can easily resynchronize our mirrored configuration again. So the tool that we want to use here is called sfdisk, and we'll use the option D to dump the partition data from the dev VDB disk. And if we simply press enter now, we'll see the exact partition layout that our VDB disk is using. So the data is currently only dumped as output on our terminal. We don't want that. We actually want to dump this data back on top of our clean and unconfigured disk. So in this case, we'll use sfdisk-d on dev VDB, or our second disk, and then pipe this through the same program sfdisk on /dev VDA. And this will basically clone the partition layout tables from the second disk onto the first disk. And you can see here that 4 partitions have been recreated for our first disk. And if we actually list the block devices again with the lsblk command, we'll now see that indeed the 4 partitions have been recreated. And now we'll have to copy or mirror the data from the existing operational partitions back on the newly created partitions. For this, unfortunately, we cannot use the control panel to accomplish this because the server is already in use and we will not get the list of available partitions. However, we can use the multi-disk administration tool from the command line to accomplish the same. So we'll simply run mdadm for the multi-disk administration, and we'll use the option --add. And now we'll have to add every multi-disk device and assign it to the corresponding paired partitions. For example, this MD0 device, we see that it is currently assigned to VDB2 partition, and we'll have to pair it with VDA2 as well, and so on. The MD1 device assigned to VDB3 will have to pair with VDA3, and the MD2 from VDB4 will have to be paired with VDA4. So mdadm --add, and let's start with the /dev/md0 device first, and we want to pair /dev/vda2 with /dev/vdb2 and press enter. Now you'll get the message that the device was added, but that also device or resource is busy. Nothing to worry about. So let's run cat on /proc/mdstat, and we'll see that now the device have been properly synchronized and it is using 2 out of 2 partitions in the array. So let's do the same for all other multi-disk devices. Again, let's use the block devices list for our personal reference. Let's repeat the same command, however this time we'll change the device to MD1 and the partitions will have to be VDA3 and VDB3 respectively. Let's also do cat on /proc mdstat again, and we see that the disks are currently synchronizing all over again. Let's repeat the same for the final multi-disk device, which is MD2 on /VDA4 and VDB4. Press enter. We can also here execute the watch command, watch-n1 on cat /proc /mdstat, and see how our partitions are getting resynchronized in real time. You should allow your server to finish resynchronization process. That is the recommended way to go. You can of course still use your file share. It will work perfectly fine. It might just be a little bit slower, so if you're in a rush, you can go ahead and access your file share, or you can wait for the process to finish before you can use anything else. And there we go. Our multi-disk RAID array devices have been resynchronized, and now we can press Ctrl and C to get out of the watch command. And let's run ls-blk to list block devices again. So we see that the multi-disk devices are now in proper sync with the multi-disk devices from the first disk onto the second disk and vice versa. Let's also start the control panel again to see if everything is okay. Let's go to hardware and Linux RAID. And here we see that the status has reverted back to all green, which means clean and active. Now, one more important thing left to do is that even though we have resynchronized our RAID arrays, we still have to reconfigure our boot partition, because this one, remember, is outside of the RAID mirror. And since we have added a new disk, we'll also have to clone and reconfigure our boot partition and the bootloader again. So unfortunately, this would be the only annoying and redundant step that you have to go through over again. So let's do that quickly. Let's run the EFI boot mgr command again with the -v flag for verbose. And here we see that we only have the boot entry number 6, or the Debian 2 that we have created previously for the second disk. However, in this case, since we have the reverse scenario, we are missing the bootloader or the boot menu entry for the first disk. So let's create that. We will run dd again to clone the disk or to clone the partition, which is input file equals on dev vdb1 in this case. So we want to clone the vdb1 bootable partition onto the vda1 to be also the bootable partition as well. So dd input file equals /dev /vdb1 and output file equals /dev /vda1. Press enter. Let's wait for the process to finish. And finally, let's add the other boot menu entry now. So EFI boot mgr -c for create, -g for GPT, -d for the destination disk, in this case /dev /vda, -p, partition will be the first partition, -L for the label. Inside double quotes we can enter Debian, and -l inside single quotes we'll specify the path for the grub bootloader settings. So \EFI \Debian backslash shim x64.efi and press enter. And there we go. So let's reboot our server one more time. Type in reboot, press enter. Let's reconnect it again. Let's check the status. Let's see if our file sharing is working. And yes, it is. Everything is back to normal. So we have successfully recovered from a failed disk scenario. Now let's examine fail scenario number 2. What if, for example, the motherboard on our server simply dies one day? What to do next? Well, the good part with a storage system like this is having the ability to pull off the disks from the failed server and move them into a new server or any other system that runs Linux. And this way you can easily mount all of your existing RAID devices into a separate folder on any other Linux machine and pull your important data that you need. And the best and the most convenient way of how you can accomplish this task is by using a live Ubuntu desktop installation USB disk. So all you have to do is navigate to ubuntu.com, go to downloads, and simply download any version of Ubuntu desktop. It doesn't matter which one it is. The next step will be to remove your disks from the failed server and move them to a system from where you would want to extract the data. And obviously, you would have to boot this system with this live installation Ubuntu Desktop USB. So, in order to flash the Ubuntu Desktop on your USB stick, simply use the same method that you used previously for the Debian installation. Now I'm going to remove the disks and attach them to another system and boot this system with this live Ubuntu USB flash drive and proceed from there. Okay, there we go. I have removed my 2 hard drives from the previous system and I have installed them into another machine, and also I have booted that machine with the live installation USB disk for Ubuntu Desktop. And all I need to do here is simply press enter and choose Ubuntu. Now here we don't want to actually install Ubuntu, but we want to run it from the live installation USB stick. So let's click on Try Ubuntu, and this will boot the system into a live temporary session. Okay, so now that we have our system up and running from the live and temporary installation environment, we need to access the terminal from the Applications menu down here in the lower left corner of the screen. So click on Show Applications, type in Terminal, choose the application. Let's actually maximize this. Press Ctrl, Shift, and plus to increase the font size. I think that should be quite sufficient. And let's become the root account by running the command sudo su. Press enter. And let's check if the multi-disk administration tool is also present on this system. It's not, so we have to install it. Let's run apt-y install mdadm. All right. Finally, let's run lsblk to list our block devices and make sure that our 2 disks are here and ready to be configured. And yes, they are, as you can see. So right now we can call the multi-disk administration tool to assemble our previous and existing RAID mirror configurations so that we can mount them elsewhere from where we can extract our data. So here we can use the command mdadm dash dash assemble dash dash scan and dash dash run. And this will basically automatically scan for any multi-disk RAID configurations, assemble them, and automatically run them. So let's press enter. And we can see here that multi-disk devices 0, 1, and 2 have been assembled and started with our two drives. So if we run the ls log command again, we'll see that indeed our multi-disk devices have been assembled. And now we want to extract our data from those disks. If you remember, the MD2 or the multi-disk device 2 is the only partition that we are worried about here. So basically this is the share partition that we actually need. So we are going to mount this share partition onto an empty mnt folder and access our data from there. So let's do mount on /dev/md2, and we want to mount this on /mnt folder. And that's it. So let's list the directory contents of the mnt folder, and we'll see that here we have our private and the public folders available. So let's run the file manager here. And let's now navigate to other locations, choose computer, choose the mnt folder, and there's our data. So in this case, what you would usually want to do is simply insert a removable external disk device into one of your USB ports and simply copy and paste all of the data and all of the folders that you need onto that external drive. And by the way, when you insert that external drive, it will appear here below the Other Locations tab, or you can simply click on the Other Locations and access it from here, from the devices list. So that's it. This is the end of this video. I hope that it was informative for you. And if you did enjoy it, please make sure to comment, like, share, and subscribe. And I'll see you in the next one.